Well, hello other side, hello MG, hello Magbecker, welcome everyone into yet another walking live stream, but this time we'll be walking with Muff. Big shocker, since that's basically what I've been doing last times, but this time a bit more because there are a couple more fun things to do. I know you can't see anything, but that's because I, as always, started the live stream unprepared, because that's just what I do. Anyway, in the background let's play some music. How about Soda KC, youtube.com/@SodaKC on YouTube, where you can go and subscribe. I'll listen to more of this music in the background that you hear right now. Let me just play 20. Boy, that's loud. There we go. Awesome fridge as always. I have my audio screwed up. Perfection. Everything is in perfect walking order. So how are you all doing? How is all of your day going? I feel like the music is still way too loud. There we go. How are you all doing? Hi, the job. How are they? How are you all there? I'm a bit dry. Okay. Let me now show you the screen. There we go. And so yeah, today we'll be doing, as always, 3D animations, but this time with a bit more math. Kinda sick, but I'm always ready for some math. Oh no, what kind of sick? Is it the light kind of, or the sinus pain, wished I was there, the really painful kind? Which kind of sick? That is awful. Also, is it something serious, something light? Or maybe you don't want to discuss it on stream and I'm really pressuring you right now by putting you on the spot. If that's the case, I'm really sorry. Anyhow, rotation. That's what we'll start with. We will start with rotation. A very fun kind of rotation, if I may add. And for that, we will need to start a new one. No. Open Geometry Nodes Matrix. Now right here, oh, this looks still insane. Now right here what we have, if this is the right file, then I'm pretty certain, yes, we did a setup in which we have a matrix and a vector. And this is basically a matrix transformation of this set vector, which is really nice because using this setup we can do geometry nodes, or rather rotation. So here's what the basic idea will look like. We'll have a... Okay, let's erase everything. So I feel like, oh, there's so many things. So far it's going out of view. Let's have one more 0, perfection. And there we go. The Matrix, like that one movie with Keanu Reeves. Yes, precisely like that one movie with Keanu Reeves. Is that's a Matrix reference, a Matrix reference. Oh, is that Iced Over by Soda KC on YouTube? Go listen to more songs if you want it. If you like what you're hearing in the background, go listen to more songs. It's pretty great. Anyhow, here's basically what we'll do today. We have a 1, 0, 0. Okay, everything's perfect. Now, wait, why is this rotating? That's wrong. Is it? Wait, is that wrong? Yes, it is. It is wrong because that shouldn't be the thing that's rotating. Clear all keyframes. This one, hold on. What program is this? This is Blender, program I use for 3D animations and 3D stuffs. So, oh, this is really screwed up. So here's what I would like to do today. I would like to showcase how you can use matrix transformations to produce rotation in a way which will make it, pun intended, obvious to anyone, even those who don't like math. What video editor do you use? I use Premiere because I don't know. I'm just used to Adobe. Yeah, that's kind of the only reason. Also, I have a discount. That's probably why. Anyhow, right here. Wait, what's going on? Okay, there is no rotation, which is accurate. Now, this should be a 1. This should be a 1. Wrong. This should be a 1. This should be a 0. This should be a 0. This should be a 1. Perfection. This is a basic matrix. It's blend, I think. Yes, this is the delay. It shouldn't be. I said ultra low latency. Oh well. Anyhow, standard matrix. Now we would like this to be at 10 meters, 10 meters, 10 meters. So there we go. Now all of these arrows are equal. Now what we'd like to do is we would like to showcase how rotation works, which means we'll start with these. actually no. This is where the tricky bit comes in, because here's basically what's happening. If we would like to rotate this arrow by 90 degrees, we can do it using matrix transformation. This is our matrix, so first column, second column, third column, and if we right here exchange this to point, so basically when we have a matrix that's supposed to rotate this by 90 degrees, we want this arrow to face this way, right? We want to rotate it by 90 degrees. Okay, makes sense? Okay, yeah, that's what we want to do. We want to rotate this arrow. Now, in order for this arrow to rotate, what we basically want to do is we basically want to move these component arrows around, which means that this red one will still be pointing in this direction, that won't change, but the green one we want to point down, and the blue one we want to point right, which means that the green arrow, instead of having coordinates 0, 1, 0, has to point down. All the linear algebra PhD is coming back to me. Don't worry, it will be, okay, at the end of the live stream, not at the end of the live stream actually, at 1/3 of the way to the end of the live stream, it will all be perfectly clear because we'll already have the animation all set up. So in order to rotate this, we want this to be pointing straight down, which means -1. There we go, now it's pointing straight down, and we want this arrow to point to the forward this way, which means we want it to be 1 and 0. And there we go, just like that we rotated this arrow around by 90 degrees. No matter where we move it, you can see that right here we still maintain a 90-degree rotation. Actually, right on the money. See? That's what matrix transformation does. It changes the component arrows around. Alright, cool. Now, there's one more issue with what we did basically, because we can also add one more thing. I'm guessing that's what it is, right? Wait, what? What's this doing? Yeah, this is supposed to be a value. I'm an idiot. No vector. Am I correct or am I wrong? This one, x, y, z. Yeah, we would prefer it to be just a single value. Nope, wrong x into all of them. Now here's what we basically want to achieve. We want to achieve an animation in which this arrow is just slowly rotating around to its new position, right? So the purple arrow is just slowly starting right here, is just rotating over here. The issue is, right now we can animate this using this X scalar right here. We can animate this, but the issue is this scalar will not rotate the arrow. It will instead move it in a straight line. Let me show you. This is what's gonna happen. We're gonna have a straight line. If it's gonna walk, that is 1, 0. And also, for some reason, these never walk either. But yeah, straight line, straight down. Right? There we go. That's not what we want. We want it to rotate around. Oh, would you look at that? Make it, the theme 3 is playing in the background, made that by Solar PC, I mean, I don't know. Yeah, we want it to rotate, not move straight down, because right here we're shrinking the arrow, basically, not rotating. So how could we achieve that? Well, we could achieve it using math. So, rotation, that's gonna be fun. Basically, we can imagine a circle. We can imagine a circle, 90, we can imagine a circle like this. We want this arrow to move along this circle. I know it's invisible when I'm not actively hovering over it, but yeah, we want to move around the circle. How could we describe this mathematically? Great question. And honestly, I have no idea. I'm gonna figure it out on stream. So, what do we know about the circle? Well, we know that we have two coordinates. At any point, we have x and y. And we know that the hypotenuse is always equal to the same thing. So, hypotenuse is constant, alright? constant, which means that h, and we also know that hypotenuse is equal to this from the Pythagorean theorem, obviously, which means that root of x squared plus y squared has to be constant. Okay, so that's what we want from this arrow. We want its position, well technically it's y and z, not x and y, but whatever. We want its x squared plus y squared coordinate, square rooted, to always to be equal to the same value. It's not gonna be all that easy actually, because now the question is of how we implement this. Well, that's simple. We would just check. Is it simple? Oh damn it. Any ideas in chat? Okay, so let's say we move on to 20 frames, right? Right here we can see that the length, this length from the center to the end of the purple arrow, is shorter than the from the beginning to the end of the yellow arrow. We want them to be equal, which means the purple arrow has to be longer. By how much? Okay, I'm looking for something mathematical. What's this video going to be called? Math for Quantum Mechanics. That's going to be the title of the video. It's going on the line, not something we want. We want to go further. Actually. What is it with no, this will be too simple. I mean, I guess we could use some non-uniform. Does absolutely. Oh, because it requires 3 vectors. Well, makes sense. Well, wait, non-uniform. Huh. I mean, we could, I suppose, use color mixing, because color mixing is a bit more complex, but it's still using only 3 values, right? Red, green, and blue. So 3 vectors. It's the same idea. So we could use color mixing. So I guess for colors you would have between 0 and 1. Yeah. This is tricky. This is really tricky, because I have absolutely no idea how to do it. Yeah, I have some idea. As I mentioned, we can use this to define our circle, right? X squared plus y squared square root is equal to a constant. It always has to be equal to a constant. Circles bring trigonometry to mind. Maybe. Hold on, I'm just trying to. What we're basically trying to do here is we're trying to move the circle. I mean, this really brings me e to the I theta, but we can't use a complex plane. That's not how it works. We can't just insert a complex plane. No, we switch it to a complex plane out of nowhere. This is really tricky. Circles bring trigonometry to mind. I mean, hi the lemon scientist, welcome to live stream. I've never used this blender before, sorry, I can't help it. No, it's not a blender thing. Here's the thing, we have 3 coordinates, right? X, Y, and Z. And what we're basically trying to figure out is, over the course of the animation, like for example, if we go to the 40th frame, we're basically trying to create a function which takes in the frame, okay, F, capital F, takes in the frame and gives us back the X and Y coordinates. So gives us back a vector of X, Y, and Z. That's basically what we're trying to create. It doesn't really... Well, the simpler the function, the nicer, because it wouldn't take me, 5 years to implement it. Or we could find a mathematical solution to the problem, in which case we wouldn't have to worry about any functions, we could just... So mathematical solution with matrices. Because right now what we're doing is we're going straight from 1 0 0 0 1 0 0 0 1 to 1 0 0 0 0 negative 1 0 1 0. So we're going straight from this matrix to this matrix, which may not be something we want. Hold on, how would you define... That's a better question. Oh, that's actually a pretty sweet question. When you have a matrix C, right? 1 0 0 0 1 0 0 0 1. This is the most basic kind of matrix C. How could you create a how could you create a function into which you input an angle and it gives you a matrix B, C, D, E, F, H, I keep looking for J, which would give you back a matrix describing this rotation. So input rotation gives back a matrix. Well, we know that the first one will remain unchanged because we're rotating around the x-axis, we're rotating around this axis, so this won't change. Which means only y and z would change, but in what way? Let's first try to rotate it around 45 degrees. How would we rotate it 45 degrees? Well, for 45, we want green arrow. I think I found it. Is the function taking the current xyz vector as an input? No, because we only need the matrix C. We'll basically use the matrix C. Oh, it's gone. Function is only taking an angle and gives us back a matrix C. Or to be exact, to be all fair, free and exact, it would give us something like this: 1 0 0 A B C D E F. This is what it would give us back, and to be even more exact, it would give us 0 0 A B C D, because we already know that these will remain unchanged since we're rotating around the x-axis. Which means we want some sort of function into which we input this, and it gives us... Oh yeah, this is... What am I doing? I'm an idiot. We're doing it in 2 dimensions. A, B, C, D. Yes, that's what we're trying to do. We're trying to figure out the function into which we give an angle. So we give this angle, for example, and it gives us the coordinates for this arrow and this arrow to end up on the edge of this circle. That's what we're trying to do. So 2 arrows which we went... Wait, I just get it. Hold on. Okay, so we're basically trying... I think I might have gotten it. So we're trying to create a function which takes in an angle. What is the yellow arrow again? Is our original vector. Our original vector which we can move around. So this is the vector we input. So do I have them on the... Yes. This matrix transforming this vector gives us this vector. That's what we're doing. I still think it's so silly that like basically this text is literally in front of our camera. I literally placed it there. It was just silly. But yeah. So, hold on. I think I got something. We know that x squared plus y squared square root is constant. And this arrow gives us this matrix. What it basically means is x0, y0, x1, y1. What is the difference between f inside letter and y? You mean what's the difference when you have f of x is equal to y? You mean what is the difference between this and this? I mean it's equal. So this is a function, and this is the result of the function. You can think of it kind of as in... You can think of it as a machine, right? F of x is the machine, x is the stuff you input into the machine, and y is what you get out of the machine. So once you place x inside of the function, inside of the machine, you get back y. And so it's equal because placing a certain thing inside of the machine, it's not a great explanation. I don't know. That's just, f of x is just a function and y is just a number. This is just a plain old number. This is a function. So we have these, and x is equal to x0 plus x1, y is equal to y0 plus y1, which means that the root of x0 plus x1 plus squared plus y0 plus y1 squared is always constant. Okay, now all we have to do is solve it. So, okay, it's constant, which means x0 plus x1 squared plus y0 plus y1 squared is equal to root of c, and then, oh boy, that's gonna be a lot of numbers and variables. I don't know if I wanna go this way. So when you say takes a frame, it takes in the current xyz coordinates. We're trying to figure out the coordinates of the end of this arrow, the xyz coordinates. Actually, we can break it down into two. First, wait, that's a great idea actually. It's just trigonometric then. Given the angle, we can represent x as and y as x is equal to r cosine angle and y is equal to r sine angle, and where r is the hypotenuse. Yes, because wait, that's actually, wait, Magbecker and Wursena, you both just, I'm pretty certain, oh, that's a great idea. We can actually divide it into two different problems. First, getting the x, y coordinates of the arrow, and second, representing those x, y coordinates with a matrix, which means that Wursena is right. X, y coordinates can be represented like this, which means, oh, this is going to be tricky. I actually might need to implement it in a whole different way. I might actually need a new set of arrows. This new set of geometry nodes, then we can group those because it's a mess. There we go, much simpler. And now only two things. So first of all, finding the coordinates for the purple arrow. Purple arrow is right here. This is the purple arrow, and it starts. Where's the vector 1? Wait, what? Where's this vector 1? Oh, this is the beginning, and is this the offset? Wait, what? No, this is the offset. Wait, did I just get it backwards? Is this the end? This is the end. Okay, this is the beginning, this is the end. It's backwards, but whatever. That's fine. So, just join in. What's happening? We're having fun. We're doing math. So, speaking of math, math note. X is equal to r cosine angle. So first of all, we need to figure out what's the r. What's the distance? Well, distance between them is equal to 10, 10, which means, well, can I just get, oh yeah, vector, no vector math. There's a simplified way of doing it, it's just length, 0, 10, 10. Alright, so that's our r. Yeah, I know, but I just didn't want to write down nodes, because can you imagine if we did square root, then x squared, y squared, summed together? It would just be a mess. I just want to do it in a simple mode. Now, what we want is cosine, cosine angle, this, multiply then copy them. Actually, no, don't copy them. That's silly. And copy this, and that will be sine. I could double check it, but I trust Watch Nana with my life. X, Y. Well, it doesn't really matter X, Y. It's not relative in this case because we're working with Y, Z anyway. My point is, now, if we take this, combine X, Y, Z, plug it into our purple arrow as an input, and then Y, Z, I screwed up. It's oscillating, which is accurate. It seems okay. What did I screw up? X, so Y in this case, and Z, which is Y. What did I screw up? Length of no. Wait. What did I just screw up? Hold on. As we increase it, it's going back and forth on the Y axis only. Why is it only going back and forth on the Y axis? Because I forgot to plug it into the X axis, maybe that's why. Make it, you bloody... There! Isn't that cool? There we go. We have an angle. Sick. Cool, great, fantastic, lovely. Now the question number 2, which is, how do we represent this angle? How do we... Okay, now we have to match these 2 arrows to this angle. Which should be easier, I think. Should be. Should be. Oh, by the way, we also have to move it around. Oh, are they different length? Okay, yes they are, because this should be 10. And now we also want to move it around this way, which shouldn't be that difficult, just have to match the X coordinates actually. But I'll just add the vectors, well, that's the issue. It's a bit more complex than that because the thing is, I'm doing this so that I can showcase how matrices work. But the matrix that I'm describing isn't used for rotation. I want to basically create a matrix for rotating around a shape. But the problem is the... Okay, let me show you what I mean exactly. Let's say we have a monkey, right? We have a monkey. Beautiful, beautiful Suzanne. Okay. Now I want to showcase how you can use math to rotate the monkey like this. Okay? Using a single matrix. Here's where we meet the problems, because the matrix describes the monkey going from this position to this position. But the matrix doesn't do it using rotation. It only moves the points in a straight line. So for example, its nose starts right here, right? So its nose starts right here, and then it ends right here. Which means the way matrix would do it is it would just go in a straight line. And that's a problem because that's not really rotation. That's not really rotation, as you can see. In reality, it's going around a circle when you're rotating it, but... So, how do you add custom things to the objects menu? Just pulls out the monkey. Custom is the object menu, you mean how they add this? No, Suzanne is default. Suzanne is a default mesh. Suzanne is default Blender. Is the teapot, is the, what's it, I don't know what's the name of that teapot. What is that teapot of Blender basically? So here's what we want to do. Geometry node editor, and we want to plug in into this, the X coordinate for, wait, that's an empty. Do we have a position of an empty anywhere? We do! Fantastic. X right here. Is it right here? No, it's not. Why is it not working? What's... Damn it, there's always something, isn't it? Wait, why did we switch this to 0? Oh, all of a sudden works. Fantastic. Does it though? It doesn't feel like it's working. It is! Never mind! I never doubted anything for a second. How should I get started with ape chemistry? Don't. I'm sorry. Just. Oh, hi there, Ali. By the way, how you doing? Welcome. I mean, I will make it. Okay, soon I'll research chemistry myself. Ask me that question then. In like a week or 2 weeks. In 2 weeks, I'll make a live stream dedicated to researching chemistry. So, or maybe even a week and a half. Ask me that question then, and I'll just have all the answers that I need. Okay, so there is something called the rotation matrix, which is just cosine and sine thing I talked about earlier. Yes, precisely what I need. Oh, yes, you are so smart. I could have just checked it on the internet actually. Wait, hold on. Wait. Oh, we can figure it out for ourselves if we're smart enough. Hold on. Oh, it's on Wikipedia. I know, but listen. We're smart boys, we can figure it out. So, basically, hold on. This is big brain time, okay? We have a circle. Beautiful. Good enough. I'm not even drawing that again. We have a circle. We have an arrow which is going right here from the origin. Then we have another arrow right here. Angle between them theta. Because I like theta, alright? Now, we have coordinates x and we have coordinates y. Well, technically this is a negative y, no one cares because we're busy doing math here, right? So we have coordinates x and y. What we know is so we know the position of this point because it has the coordinate of x and y. It's a vector, right? X, y. Now, what is this angle? That's a great question. Some of you might remember Toa. Lord remembers, I know that because I have a brain of a goldfish. I need this to remember. Which basically means it's sine opposite divided by hypotenuse, cosine it's adjacent divided by hypotenuse, and tangent, which is opposite divided by adjacent. Now, what we want is we know this, the radius. Or hypotenuse, whatever you want to call it, because it is the x squared plus y squared root, which is equal to r. I could just, yeah, you are all right, by the way. Yeah, I could just check it on Wikipedia, but isn't that much more fun? We're doing a math stream, which means we're gonna do some math today. Okay, now the question becomes, when we start with a vector of 1 and 0, what matrix do we want to apply onto it? x0, y0, x1, y1. What matrix do we want to apply onto it in order to get our position x and y in a way so that these values are dependent on the angle theta, and that's it. They are only dependent on the theta. Math is really only fun when you decide to just discover stuff instead of looking up. I know, right? That's why we're doing this today. No spoilers. We'll figure out for ourselves. So, us watching directly. Okay, well, you know what? Let's prove everything ourselves because might as well. So right here we have a triangle. This. Yeah, that's a good question. Wait. We have a triangle. I want to do it right because I always screw up on the very beginning and then it screws me over the entire time. Because we don't want to, we have to rotate all the way. So it has to also be true for points right here, points right here, points right here. Wherever we are, it has to be true. So we care about this angle theta. You know what, let's do it for 2 points. This point and this point. This is x and this is, no, wrong, I already, okay. X and y. Now, we can figure out these angles easily. Can we now? Yes, but can we do it reliably? Because right here, y is the adjacent, x is the opposite. Right here, x is the adjacent, y is the opposite. They switch right in this corner. They switch, unless I'm just drawing them in. Unless I'm an idiot, because of course I am. That's what I mean. I'm always screwing myself up. Let's do it this way. There we go. And now we have y coordinate, x coordinate. We want to get this, and if I'm not mistaken, this is the formula for it. Sine opposite divided by. No, this is tangent. I like tangent. It's easiest. You don't have to calculate the hypotenuse, whatever. trigonometry. Yeah, on these live streams we tend to do a lot of linear algebra with recently we are doing quite a lot of linear algebra trigonometry stuff, which is quite concerning. Theta. So we input theta, and then we get in return opposite divided by adjacent. Opposite x divided by adjacent y. That's what we get. Right? Is that true for everything? If we keep on going right here, isn't x becoming the opposite? No, it's not, because make it quit being an idiot. Yeah, make it quit being an idiot. Okay, cool. Discovering rotation matrices for ourselves. Because we're cool, alright? I never understood why people call trigonometry hard, and I saw it in my... because that day I understood true fear. I mean, I don't think math is... I don't think it's all scary. I just think it's painful. It depends on the situation, obviously. I just think in schools they tend to rush things a lot. Like, imagine if right now I was doing this on a time limit. That would be awful. And that's basically what schools are like. They would give you a problem like this and give you a time limit. And there's no way I would be able to solve this with a time limit. I would just get nervous, scared, and wouldn't know what to do. Instead, we're streaming. We have no time limit. That's why we can approach things slowly and we can make them make sense. So we input our angle, we get x and y. Why is that convenient? So glad you asked. That's convenient because we know r. We know what r is, and from r we can get this x squared plus y squared, which means that root of r is equal to x squared plus y squared. And now we can replace... wait, hold on. Am I this right? We know what this is equal to, so we can say that h is equal to x divided by y. Now, this is the tricky part. Not really tricky, I'm just dumb. The problem with schools is like they show you how to put something into the calculator, but they don't tell you what the calculator is doing, yeah. That is always the biggest issues. They also really often tell you to be the calculator. Like really often you're just computing problems instead of actually solving them, which is also a pretty big issue. Because then, like, a great mathematician is not supposed to be, I don't know, a great mathematician shouldn't even have to add. They don't have to... Okay, I'm not putting... well, hold on, give me a second, let me prove. I'm trying to come up with some sort of ingenious quote, so it's gonna take me a bit. I'm also thinking about this in the background. We already have machines that compute things for us. We have calculators, we have computers. That's what computers do. They compute! It's in the name. And most of the time schools mostly just tell you how to compute stuff instead of how to calculate them, how to solve problems. Which is a big issue because most of the time we don't really care. Like for example, matrices are a great example. Most exercises you have with matrices are not about finding the right matrix or something like this. No, most exercises just are like here you have a matrix, just some sort of matrix. Here you have a vector, just some sort of vector. And now just find the resulting vector from this matrix, which gives you nothing, doesn't tell you how matrices work, doesn't tell you any qualities of matrices, just soulless calculation. Trigonometry is so confusing to me. It's not okay. Trigonometry is pretty simple, but once again, only if explained correctly. And it is a bit of a difficult thing to explain. Basically, should I go into... okay, make it one thing at a time. First, solve this. We have h. I probably shouldn't call it h, because that's hypotenuse. Let's call it a for angle. I think a good step towards finding the rotation matrix will be seeing how we can represent common rotations like 90, 180, 200, and as a 2 by 2 matrix. Yes, but that would be easy. Those are what's the rotation matrix? Is a matrix which just rotates things around. That's actually, but what you described, that's actually a bit too easy. That's our problem, it's actually too easy. You see, oh yeah, we have to plug in, hold on. Yes, but that would be easy. No, the issue is that it would be too easy. It wouldn't be hard enough to give us any information. Let me show you what I mean. Let's replace this arrow with this arrow, and right here I'm going to set in, is it input? The answer is no, and I just screwed something up. Right here. What is this vector? This is sum. Oh, this is a sum. Whoops, I meant this one. There we go. Here's 0. This is a rotation for 90 degrees. He's trying to find out how to represent the rotation of a line as a matrix, hence rotation matrix. Yes. So we have this vector, and we have this yellow vector right here, which just needs 3 numbers. We have this matrix, and we want to transform this vector with this matrix into this vector, and we want basically the resulting vector to be a rotation. Right here you can see that this is always a 90-degree rotation. The purple one is always a 90-degree rotation of the yellow one. This would be a bit, what I meant by this would be a bit too wait, hold on, maybe you are right. Watch Nana, I ever doubted you for a second. We're gonna need a table. Trig functions table. Because this is just gonna be 4 trig functions. This 90 degrees, no, we're gonna need full 360, yes. This right here, 90, we're interested in sine, cosine, tangent. 0, -1, 0. And these are the 4 numbers we're interested in. 1, no wait, these. 1, 2, this. So 0, -1. Okay. So first of all, 90-degree rotation is equal to a matrix of 0, -1, 1, 0. A 0-degree rotation is equal to 1, right? Am I correct? 1, 0, 0, 1. Yes. 1, 0, 0, 1. This is 0, this is 90. Now next one will be 180. In order to get a 180 rotation, we want... what I meant by too easy is that it will be just 1s and 0s, but I forgot that but even using only 1s and 0s you can already get a lot of information about trig functions. As I, the dance hat fits in. In order to get... okay, so we want y to be pointing and z to be pointing down, which means... oh yeah, just negatives. There we go, that's 180, which means -1, 0, 0, -1. And then 360 is easy, so 270. I'm really trying looking for an answer. 270, which will be, I mean this, but reversed, right? This but reversed, I'm pretty certain, which would be 0, 1, -1, 0. Yes. Alright. So what we're looking for is basically trig functions which fit in that description. So right here, 90 degrees, something that has a 1. Something has a 1 at 90, 0 at 0, 0 at 180. Is it at the sine? 0 at 180. That's a sine! Ooh, yes! It's like some sort of game show, honestly. So this is a sine of theta. times R, I'm pretty certain. Did YouTube just stop my soda? Yeah, it did. How many of them? What are matrices and what do they do? Great question. We'll answer it in a second, but I'm having my Oppenheimer breakthrough moment at the moment. So this is the moment where, you know, I'm having my Iron Man gif figuring out the new element moment. So well, not really, I'm just trying to find ones and zeros. Now this one has 1 0 negative 1 0. So 1 0 negative 1 0 cosine this one 0 negative 1 0 negative 1 0 1 negative sign. I'm pretty certain we multiply by R. The multiplication by R is a complete guess, by the way. And I think it's wrong, actually. I think it's wrong, so disregard. I don't know, we'll have to check it. It's a guesstimate, so for now we're just gonna screw them up. We'll get some sort of rotation when we get these, and I'm guessing negative cosine is the last one, right? No. This one's just cosine. These are always the same. So this would appear to be... yeah, we will have to multiply by something. So this would appear to be what we're looking for. Which means we're gonna plug our arrow back in. Where's the arrow? This is an arrow. We're gonna plug it back in. Actually, no. We're gonna keep this one, and then we're just gonna change up the x and y. So, we want to change up these two coordinates of these two. So, first coordinate of the y arrow. Why is it just inputting it? Oh yeah, because this is the okay. Goes from here. Can you do a video about calculus? This video will have calculus, actually. It's a funny story because once we're done with this, we'll actually work on a separate Blender file which will be all about calculus. Once we're done with this, I'm actually going to implement, well, not really implement derivatives, that would be, well, I could. I might implement derivatives because computing derivatives is much easier than actually calculating them, so I I probably will. How about all of algebra? Will be coming. Quite a lot of things. It can be used to represent X, Y, Z coordinates. What just happened on Twitch? Ban and in-game action, non-control Z's. Fuck off. This isn't even a Twitch stream. I'm only streaming on Twitch because some people prefer to watch on Twitch. This is mostly a YouTube live stream. We're mostly here for the YouTube, let's be real. Oh wait, yeah, that's what I was doing. I was implementing stuff. So, we're looking for right here, separate. We're going to hijack these vectors, then combine. We're going to hijack them, and then we're going to replace the y and z values with these ones. So here we have an angle. This is our angle, I'm not mistaken. We're going to take the cosine and sine of this angle. That's crazy, that's so good. I think that's rather silly. I would actually call it silly. Represent data, what you do with it's up to you. I can actually show you, you know what, Bob? I'm gonna show you exactly what matrices are. How about that? Let's show you before we, because we still have this, so I feel like for uncoding, yeah, because this is okay. You have to remember that in math, what I'm gonna show you is the way matrices work. Okay, I'm not gonna show you what they are because what they are just numbers. So a square filled with numbers. Why are you using specifically Blender? Is it because it's easy to display rotations? It's because Blender is versatile as fudge. Alright? In Blender you can do anything. Like most of my animations, which I normally would do in Manim, I will do in Blender this time, because it's just so versatile and just amazing. Anyhow, Bob! I just want to confirm that you are listening at the moment, because this is a just for you exclusive explanation of vectors with matrices. I'm hoping it's gonna be a short one because I've set up this file to explain them pretty well, so I'm really hoping it explains them pretty well. It took quite a lot of work, not a lot of work, but a decent almost amount. I'm still gonna keep talking, I just need a verbal confirmation that you are... Oh, that's actually for everyone too, I suppose, to enjoy. Everyone who isn't quite sure what matrices mean, then this is gonna show you exactly, hopefully exactly what matrices are all about. So, we have a vector, right? This yellow sucker right here. This is our vector. Arrow in 3-dimensional space. And I get to watch not an arrow soon. Arrow in 3-dimensional space. Now it's made up of 3 different arrows, right? 3 different arrows. So the X coordinate, which tells you how far right you're supposed to go, the Y coordinate, which tells you how far forward you're supposed to go, and Z coordinate, which tells you how far up you're supposed to go. Those are the 3 arrows that make up this yellow arrow. Now, here's what matrices do. These are the coordinates of our arrow, right? So, how far to the right, how far forward, and how far up it's supposed to go. Now, what matrices are basically doing, matrix transformations, they are moving these arrows around, changing their coordinates. So, for example, right now, you can see that the coordinates of our red arrow is 1 step to the right, 0 forward, 0 up. Let's change that. Let's change that so that our arrow goes 1 step to the right, 0 forward, and 1 step up. Why didn't it do nothing? Oh yeah, because this is supposed to be 0. And just quick bug fix. There we go. So, let's change it, as I said, before I was so rudely interrupted by my own geometry nodes. Let's say that we want to move this arrow also 1 unit up. Not only 1 unit to the left, but 1 unit up. There we go. Now, as you can see, the coordinates of our red arrow are 1, 0, 1, because they are going 1 unit to the right, 1 unit forward, and 1 unit up. And so this is our original vector, and this is our new vector with this matrix transform. Now we can move arrows anywhere we want. We can move the green arrow down if we want, right? If we want, we can move it down. We can move the blue arrow if we want to the right, for example, and then a bit closer in. Or we don't even have to resort to once. We can just move in all over the place, make a mess, whatever we want. This is our matrixing. And now here's how matrix actually works. You have the first arrow, the second arrow, and the third arrow, and moving this vector around on the x-axis tells you just how important, in quotes, or how large, the red arrow should be. As you can see, right now the red arrow is massive, right here red arrow is tiny. Moving Y around tells you just how large the green arrow is supposed to be. Green arrow is massive, green arrow is tiny. And moving it up and down tells you just how important the blue arrow should be. So, blue arrow is massive, blue arrow is tiny. That's the graphical interpretation for what vectors and matrices are. But the key element, most important thing to remember is that this is only a graphical interpretation of what they are. And in reality, vectors and matrices aren't about the graphical stuff, they are just about multiple numbers. So in reality, this is just these numbers are the actual this is the actual matrix, this is the actual vector. Just the numbers, that's all they are. And so you can think of them as adding them just all together, but this number tells you how important the red stuff is. This number tells you how important the green stuff is. This number tells you how important the blue stuff is, or how large they are, right? This number tells you just how large this is, this number tells you just how large this is, this number tells you just how large this is, then you add them all together and you get a purple one. Vectors. What's the difference between a matrix and a table? Name. That's it. Name. That's the only difference between them. You have to remember that mathematicians... Okay, mathematicians name stuff depending on the purpose. So... you can have you can have x, which is a constant, and you can have x, which is a variable. Okay? X, which is a constant, x, which is a variable. Now, what's the difference between them? Well, they are both a number. They could be both equal to, for example, 7. Let's say they are both equal to 7. What's the difference between them, you might ask? Well, the difference is simple. The name kind of tells you what the purpose is. So if x is a constant, that means that x is supposed to represent a solid, unchanging number 7. That's all it is. It will just be forever 7. Now, if it's a variable, then x is supposed to represent a number which changes. So 7, which could later on become an 8. Or you like to see what happens if it becomes a 6. Or you'd like to see what happens if it becomes a different number like 3.14. So that's the difference between a matrix and a table. They both have numbers in a grid-like pattern, but you use table just to save numbers, and you use matrices for matrix transformations. They have the same thing, but they're used for different things. That's why the name differs. The name tells you what they are used for. Damn, I was about to tell about the same thing. Great minds think alike. What was I doing, by the way? I completely forgot. Oh yeah, I was implementing stuff. Yeah, right. I was implementing the incredibly cool thing to come. We are going to multiply it by something, I know it already, but we'll cross that bridge when we get to it. So right here we have cosine and sine, and for our calculations it would appear... I love that text is in 3D, by the way. I absolutely love it. Is that iced over ice here in the background? Anyhow, so we have a matrix, which means combine x, y, z. This is our matrix. So x, so first, so we have multiply. Also use a matrix to represent data. Yeah, exactly. It's just a matter of naming. Let's also plug in the value because we're gonna scale them all a different way. Let's bring up 5. Actually, you know what? No, math, and we're gonna add 0 because then it's easy to plug in. Plug in the actual thing. Alright, so first cosine goes right here. Then negative sine goes right here. Then sine goes right here, and then cosine goes right here. And now, first of all, let's scale it down. Wait, is it gonna be really a 1? There's no way! Oh, it's a 1? 1 is a perfect match. Why do I not need to rescale it? Wait, that doesn't make any sense. I don't have to rescale it? Is it because I scaled up the entire... No, I didn't. Wait, what? Why is 1 a perfect match? This arrow has a coordinate of 10, 10, 10. Not 1, 1, 1. Doesn't make any sense. I'm so confused. I don't know. It works. Why is it working? That shouldn't work. That should be wrong. That really shouldn't be... Okay, is this... By the way, is the angle... Oh, we are awesome. Nana, we're... Okay, I don't mean to toot our own horn, but we are kind of awesome. I mean, look at this. Yes! Oh, that is so sick. Oh, that is so cool. And what's best is that it works for any vector. Look at this. This is so awesome. How did you figure out what to multiply? Well, that's the issue. I'm not multiplying it by anything. I'm multiplying it by 1. I don't know why it's working. It shouldn't. It really shouldn't be working at the moment. I'm multiplying it by 1. Why is it just... Oh, because the X and Y going in are already scaled, that's why. Oh! Wait, what? Yes. No, that doesn't make... Hold on, that doesn't make any sense. I don't know. I don't know why it's working, actually. Because I'm so smart. I know why it's working. Oh, okay. These are just the unit vectors. Things going in are unit vectors, and right here I have a whole separate thing that's responsible for scaling them. This one, not mistaken, right? No, I don't know where it is exactly. Oh yeah. Oh, I'm so okay. Never mind. I know why it's working. Okay, okay. So these are just the unit vectors, and x is equal to a 1, but then it's getting rescaled. Okay, this is actually pretty smart. This is a pretty smart system. Okay, that's pretty cool. I guess I could have cleaned it up a bit. Yeah, I made a bit of a mess. And by a bit of, I mean just straight up a mess. These okay, yeah, I made a whole lot of mess. But the point is, it works. And now I can show you exactly what I meant with that. So, 0. We'll rotate it by... Yeah, the things will be just appearing about and disappearing. How much should we rotate it by? Just do a few things. Let's start with 0 and then rotate it by... I don't know. Rotate it by this much? Let's say, yeah, fine, that's good enough. There we go. Now let me show you something fun. Let's add a cube. Wait, hold on. Let's... How do I move it to the output? This means 0, 0, 0. How close it does. Oh wait, no, it's just in the center. I'm an idiot. There we go. And now let's create a tetrahedra. So, delete the vertices. Add. Do I have an option to just add a vertice? No, but I can. There we go. Okay, hold on. There we go. We have a vertice right now, and then we're gonna move it to different points. So we're gonna move this vertice. We should note them down somewhere. What should we do? Yeah, it's smart with math. No, I just implemented it in a different way. Okay, so the position of the first point will be equal to 7, 0, 6. Alright. 7, 0. So it doesn't really matter what the position will be, as long as we remember it. 7, 0, 6. Then the next position will be equal to -4, -8, 0, -4, -8, 0, and then that's actually really important as it goes in. Next position will be right here, -4, -5.5, -6. Then the final one will be right here. 5, 10. Okay, now here's what we're gonna do. We're gonna select all of them, yep, and we're gonna create a tetrahedra out of them. There we go, this is our tetrahedra. It's a bit funky looking, I won't lie. Why is it full black? It shouldn't be pitch black, should it? Why is it pitch black? Oh, because I'm doing it in EV, isn't it? Yep, that's why it's pitch black. This is our tetrahedra, and now we're going to duplicate these arrows, rotation tetra, and we're just going to geometry model, fantastic. We are going to merge all of them into a single group. Well, okay, move this out. Make group. Increase settings should work. Fantastic. Oh no, they're going to single join. Damn it, I didn't merge the join geometry. There we go. And now here's what we're gonna do. Oh, almost there. So we have a vector, it's going in right here, fantastic. And now we can join geometry. Have 2, 3, 4. We have to plug all of these in. These into A. Second one's into. Oh wait, but which A? Oh, why is this such a mess? No, the first one should go into A below X. Why? Why? Just why? Why is the first one going into A below X? I don't know. Right, this value goes into, because this is the angle, which means this goes to the lowest. Then this right here goes to A below X, this right here goes to A below A. My naming conventions are just fantastic. Due to lack of any naming conventions, obviously. Then we have third one going into the top, A. Use Mac or Windows. I use Windows because I use Adobe, and that's the only reason. I just use Adobe, and I'm pretty sure Adobe doesn't like Linux for some reason. Vector, and then we're gonna also have vector math. We're gonna multiply all of them by scalar. No, wait, by 3, because we're gonna rescale it to also be 3 times larger. And make this trick is happening. Where you'll see real soon. Actually, we're really close to being done. Okay, this one. 3, 4. Oh, this is gonna be the coolest. This is just gonna be straight up the coolest thing. Okay, now we just input the values. So 7, 0, 6. Oh wait, we also plug them in because of course we do. And also, if I may, I would like to lower the alpha on this a bit. I've been using Windows for the longest time, but this their friend told me even though prefers Windows for coding, because it makes the whole process of coding easier. I'm a C programmer, so I don't really like when coding is easy. I just hate Mac so much. That is fair, they are annoying. They are very annoying, and they don't like sharing with people. They don't like standards. They're screwing every single standard up. -4, -8. Like, people have to reverse engineer. Linux is great, as always. Everyone wants Linux, because Linux is just open source. You can't hate that, it's just open source. -5.5, and I do love everything open source. -6, -0.5. So I love Terra so much. Terra so far. This is pretty rough. There we go. This. Why isn't it working? Because we forgot to join geometry. That's why. Now, if you take a look at what we've created basically right now, is we just created a tetrahedra where each of these, alright, each of these vertices goes straight to, each of these vectors goes straight into a vertice of this tetrahedra. If I picked a simpler shape, it would have been easier, but oh well. Now, let the show begin, because what we want to do is we want to start with this rotation and end it with some sort of other rotation, like let's say 180 degrees. I feel like that's gonna do it. And then right here what we want to do is we want to start with 0 and end with 180. What is 180 in radians? That's, is the very big pi? How do I insert pi in Blender? I know there has to be a way. How do we insert pi in Blender? Math node, no, numeric input. So I'm looking for pi. Lowercase pi. Don't. Is that a really lowercase pi? It is, okay. Pi. And now let the wait, no, I screwed up. It's pi divided by 2, isn't it? No, why is this one? Why did these one? Oh, why is? Oh, because that's the original one. 0 wasn't the original. I'm an idiot. I should trust myself more. And there we go. We just created a matrix, which perfectly describes rotation. Isn't that cool? I mean, look at it. Look at it. Isn't that amazing? What's even better is that we can go right here. We can rotate by another 180, so we can just have 360 rotation. There we go. And right here, we can multiply it by 2. That's so cool though. No clue what's happening. Okay, so we have... What do you mean? You understand? This, I mean, this is pretty self-explanatory, isn't it? I feel like that's perfectly self-explanatory. Okay, so let's ask ourselves a question. Okay? Everyone, let's ask ourselves a question of, have any of you ever been curious of, I really like you actually, when you have a blender like this, when you have a shape like this in Blender, and you're just rotating it, have any of you ever been curious about how Blender actually rotates this? How does it figure out where the points are supposed to go? Oh, what are the yellow lines? Oh, yellow lines, that's the initial vector. Yellow line is the initial vector. The vector before the transform. So yellow is the initial vector, that's why when it's 0 they're both on the same spot. And then as you change it around, it changes. You know what, yeah, let's switch back to EV. Yes. There we go. Yellow is the initial vector and purple is the transform vector. I don't want to think that the text is just bound frames. Let me just save a new one, delete all the text. That's the text, right? Nope, I just deleted the keyframes. How can I not delete the keyframes and delete the text? I'm gonna have to just erase it. From every single one, never mind. Okay, so now that we have a clear plane, clear-ish. There are still a couple of issues because I have to do the rotation. 0 and actually, and now we can also set all of them to linear so that we have a nice loop. And there we go. So what we basically did is actually really fudging cool. But it looks like a stereotypical genius vinyl for all the text. I know, right? If you think this is it's basically mad text. I know it's that's what I like to call it. If you think that is insane, let me show you. Wait, no, that's the wrong one. Which one was the crazy geometry notes? I think. Take a look at this one. Right here is where we really went all the way in. I love how the closer you go, the smaller the text is. Yeah, we have fun on these live streams, you know? There we go. Oh, this is cool. Oh yeah, all the text is overlapping. That's so strong. Oops, I'll have to fix that. But I guess we could also render it right now and just see what it looks like. So let me just delete the overlapping text from it. This geometry nodes, that's where they are. So we have to go inside these groups, group of 4, and we have to delete the text, which is this. Festive. Let's render. Let's render because I'm curious. See what it looks like. And let's give this emission. Will it be still transparent with emission? It will be. Fantastic. I love Blender. Oh, this is gonna be cool. Okay, this is good. Oh, this is gonna be awesome. I mean, come on. Algebra, frames, basic. Rotating. How long is it gonna take? Wait, 6, 3, okay, is all correct. This is an awesome animation! That's cool. Why are we standing on third? That's because I didn't press rotate, run the animation, did I? Yes, I didn't. Okay, also it's a bit off. I wanna have it on frame, there we go. Nice. Anyhow, what else today? We've already been streaming for an hour and a half. It feels like 5 minutes to me. That is a good live stream. Make the polygon chrome the arrows emissive. I mean, the arrows already are emissive. Hold on, let me show you. The arrows already are emissive. If we set this to 0, you can see that they are already emitting stuff. The only issue is that I want this to be transparent, but at the same time I want it to be visible. So I want it to be like semi-transparent. That's why I did emission, because emission analyzes it pretty well. I guess if we do the transparent, if we do a transparent background, it won't really matter. So I guess then I could really. There we go. Chrome, you say? That's just gonna make. Oh, that's so much more confusing though. Go metallic all the way. I could also do this. I don't know. That's so much more confusing when everything's just reflecting. That does look amazing, but there's so many more arrows now. Wait, we have EQR for a basic? Why? Metallic all the way. Oh, we can have a code. Oh, what just happened on Twitch? Ah. Make it as the most sophisticated attendees. Codes and C prefers just inventing muffle while looking up in streams every day. Oh, someone just followed. Hi there. Hello, Sulu. I listen, charity, right? HTTP's construction make it out with charity stash. We go need some money. Charity ain't get the size of pie for yourself. Right now we're collecting money for charity DBS Alliance. Depression and Bipolar Support Alliance. We've already collected over $1,000 and we're still collecting, so if you like, just go and donate. We can apply a code which reduces roughness. I don't know if I like it. Where's the Sheen? Sheen is also something. No, just wait to 0. I like the emission of that, but you know what? Yeah, I guess if we have the background transparent, that doesn't matter. Just oops, wrong way. This one. There we go. I see wrapping in my video. Jeśli jest konstruction get average charge stash, we can go into my charging get a 5 for yourself. Once again, jeśli jest construction get average charge stash, we can go into my charging get a size of 5 for yourself. Right now, going money for charity DBS Alliance. Look at description. Jeśli jest construction get average charge stash, we can go into my charity DBS Alliance. I'm stuck. I'm having a stroke. He breaks up random routes. That's my. Oh, yeah. This is quick now. 15 seconds per frame on this. This is pretty quick. Chronic condition. Chronic rapping condition. I mean, I'm 1p away from a felony, so you know. This is not one. We will also, today, do... What will we do? We will do calculus, right? I feel like I'll render 2 versions of this. Or maybe 3 versions, or actually maybe more. Like this is a full one, then I'll rotate, then I'll render some without the yellow arrows, some without the purple arrows, some without the mess of arrows everywhere. 3D shape of vectors, yes. I mean, if you think about it, every 3D shape is just vectors, right? It's time to create another folder. Calculus. Almost misspelled it too. Basic setup. Now for calculus, I would like something. I would like a scene that's a bit nicer, you know, something that's a bit, you know, a bit of a, you know, right? There's a bit of stuff. What are your views on the current socio-economic state of the world? Well, it's actually a pretty complex issue, but I do believe that in many cases power hunger is a big problem, because you see, when you really often group power together, it leads to potential for more power. And socio-economic in this case doesn't really matter, because you know, both like economics and social, both are just ways of measuring the, once again, power over the general global population. So, for example, you have certain organizations that are responsible for monitoring the inflation of different currencies, right? Now, this monitoring of inflation is important because it allows you to actually check how much valuable certain currencies are. Now, inflation, default set up inflation, because they control inflation almost completely, which means that 2% is not actually an error. The 2% inflation is a goal. Line goes up, more people buy more things, which on one hand may seem like a good thing, but on the other it's a bit of a problem, because then people who have more money can make more money off inflation. People who have less money are less fortunate, and this leads to more problems. So what are we talking? Math, right? Yeah, calculus, that's what we're doing. Okay, so cool. So let's first start with the background. So for the background, we'll do something nice and simple. Whoa, there we go. Noise texture, that's what we start with. Noise texture. That's our lovely noise texture. Now what we're gonna do is we're gonna take a color ramp, and we're actually gonna take a factor of this. There we go. I thought it was antisocial, and that's where he created the channel for charity instead of doing something like creating a soup center. Would you ever make more non-assemblies, like if you can I know, I keep on making quantum mechanics videos, don't I? And I hate myself for it. I feel like a one-trick pony. I mean, I did do the electricity with electronics, I will make a politics video soon. A video about politics, not about political things, only about politics themselves. It's just... That's a very risky kind of video to make. And I will make it soon, pun intended. It's gonna take a while. So it's the roughness to, let's like 180 this way, let's say. Right, that looks solid enough. There we go. And now what we're going to do is just gonna add a splash of color in. So blue. And then red. And not red all the way, only in between them we'll have yellow. Looks like garbage. Looks like hot garbage, in fact. Guess what? I managed to get it right on the money once with the background color. Because I could just, you know, desaturate this and you could have something like that, which is decent. Make it the on grid mythology, that would go hard. Actually, maybe. I've never thought of that. Making videos about mythology. Maybe we could do red in the center. Ooh. Spicy! Maybe. Can't solve it. It looks somewhere in between rendition and fungi growth. That's kind of what I'm going for. I just want a cool looking background with some complex shading. Because that won't matter, because we'll add a floor anyway. For the floor, I need to open up Blender 3.5, not 4.0. It's an old version. And I'll need to open up another project of mine. That's a really specific look to go for. Thank you. I don't know if that was a compliment actually, but thank you anyway. It is a very specific look to go for. I just like it. It looks nice. Spacey look. I'm looking for this intro, not intro only, software and floor. Oh, it actually copied in. That's nice. Yeah, this is the floor we'll use. This floor should be inside of a collection called H, and we should hide it from the world. And all of this should be scaled down significantly. Where's the cube? Way more. This is a bit hard on me eyes, but this basically is what kind of we're looking for. Screw should also be hidden. Do you like this factory floor? I made it myself. I made it. I made it myself a really long time ago for a whole different project. There we go. Now I would like to change it up a bit, though, this time. I would like to add a plane, size of the entire thing, with an emission shader, set to light blue, power of 10, move it down, right below it. If you don't mind asking, what's your educational background? I bring out a ton of vids. I love the channel. Binging a ton of vids, and I love the channel. Oh, funny story actually. I don't know if you're asking me about that, but I don't have an educational background. At least not a significant one. I don't have a PhD or anything actually, or any degrees of any sorts. I'm just bored. That's my educational background. Wait, what? Yeah, fuck. Crazy, isn't it? I'm just bored. Okay, so hold on. I've set up a really long time ago, but the distance between them which node controls the distance? This node, okay. So we wanna add math. Like, there we go. This one's good. And now, if we render it, we should get a thin blue line in between them. Fantastic. Delete this line, it's not necessary. There we go. Though I'll be a homeless guy in the streets. Mate, I'm a YouTuber. YouTubers either live in mansions or are homeless. What do you think I'm streaming? I'm actually streaming this from my local library. They're gonna kick me out soon because I broke in. Won't tell me better? Okay, then that seems kind of decent. I'm looking for that futuristic factory look. I don't know if I'm capturing it exactly. I could switch the color of the background. It's gonna be low jittery, so I'm really sorry for that. If you're wrong, so see. I've even thought about becoming a school teacher someday. That would be great social studies or science teacher. I mean, I kinda am. I kinda am a teacher. It's just I make videos on YouTube. I know, but I'm kinda good with Blender, and I feel like I wouldn't use that much. Grandma's bringing by super complicated math. Yeah, so the tangent of the hypotenuse Fourier transform Laplace, and then you take the theta angle of the sine wave function, and why is it that the only kinds of math I know are related to quantum mechanics? I really am a one-trick pony. That sucks. I'll have to change that. Is this a good look? I don't know. I can't tell. Maybe if I dim the light on top. I kind of like it. Only kind of. Hold on Twitch, so bro, hold on a second, speak slower, I don't speak. The sound code funny. That's mad depressing, formal background. How do you put together all the stuff usage research wise? I'm just bored and lonely. That's how I do it. Honestly, those are the only two things you need: being bored and lonely. I mean, is this channel monetized? Yes, it is. Yes, it is actually. Quantum mechanics video. That's what quantum mechanics video monetized this channel, all by itself. Say, do you really have any friends? I do. I mean, I've met all of them through YouTube, but I do. Not online. I don't. But like, what's wrong with online friends? Oh, you're unbelievable. You have friends. On Discord. Oh my, whoa, Windows, no, don't crash. Oh jeez, that hurts. Stop it, stop that. Windows, please. Wow, that was awful. Ow, that hurt. Ouch. How many years out of high school are you? Oh, you want my age, don't you? I always bring up the same answer, which, well, here's the thing. For some reason, for some weird reason, you have a safety hat though, like dance cap. For some reason, all anyone ever cares about is my age. I don't know why. That's what everyone cares about. It's just how old I am. And that's precisely why I don't want to tell you, because I feel like it wouldn't be fun. What's the fun in just telling you? You should be allowed to wonder a bit. How many seconds have you been alive for? At least 7. Maybe. At least 7. Something like that. Maybe 8 even, I don't know. Funny sure I actually can't count down. How close are you to dying? You are exactly 23 years old. That's a solid guess. Am I close? Yeah, you are. You are close. I mean, you know, closeness is relative. You could be 10 years old and it still could be close, but you know, yeah, it's kind of close. I'm actually 13. What does the D stand for? It's a dance hat. Oh, we've never seen a dance hat. Let me show you what a dance hat is. Dance hat. It's a dance hat. A dance for dances. The man's fault. Asylum seekers to where dance has dropped. That's okay. It's a dance hut for people who are dense. I recently did a, well, not so recently anymore, but a while back I did a quantum mechanics research live stream, and so I just put on the dance hut because I know what to do. Have you read the history of dance hut? No, I have not. Is it bad? Because if it's bad, I might have misused it, and oh no then. Please don't tell me it's bad. It was invented by Hitler, wasn't it? It's gonna be something like that. He said he's 7 seconds old. We know he isn't a newborn. Damn it! Damn it! What's that on to me? I thought it meant dumb guy who needs more subs. That's also what it means. Subscribe right now. Link in the description. Or not in the description because you're watching the stream. Even though I don't understand the things you talk about often, you're still entertaining. You have a really nice voice and you are super chill. Thank you so much. I really appreciate that. Okay. Also, you're really quiet. Are you like on stream or as a person? Because if on stream, then I can make seconds. Isn't a newborn after like 1 month? Yeah, we did, mate. That, you know what? More people should be acting, more people should subscribe to me. Oh, you're multi-streaming, aren't you? Kind of. I'm streaming with both OBS and Twitch, so... No, I won't read that. Suck it! Haha! I'm one step ahead! I'm trying to think of a way to optimize this, honestly. I'm pretty certain the way I set them up is there is a value in there which I can just tune, which is responsible for this. Increasing the size of the floor. I could just increase it marginally. Right, okay, there we go. Will it? I'm scared of rendering it because it's gonna break again. Don't break. Yes, dude. He's too tall to be 13. How would you know? I'm pretty certain there was someone who genuinely thought I was underage, and that's kind of insulting at this point. That's mean. How tall are you? Ooh, I'm short. 5'2", maybe 4'8", maybe 1'7". How far from 7 feet are you? Quite. Okay, I'm short. I'm actually not that self-conscious about that. I'm just short. I mean, yeah. The creator of Dance Cup thought in some metaphysical way act as a reverse funnel for knowledge, with the wisdom flowing into the pointed tip and spreading into the brain below. That's quite an origin story. I have my phone volume on max and I can barely hear you. There you go, let me just tune it up then a bit. That should be better. 20 feet, 20 feet away. Growth spurt. I don't know. I stopped growing years ago. I just kind of gave up on hoping. Oh, this is awful. Oof. Youch. I'm pretty certain I've reached the end of my growth. Like, really, really decently certain. Maybe that's why I just accept the fact that I'm short. That's sad. What do you mean that's sad? Being short has advantages. I'm always last to get hit by lightning. He's not a teenager. I mean, yeah, I feel like it's obvious that I'm not underage. I am earning money, so, you know. It's kind of a bit of a giveaway. The end of the growth spurt at 19. At least 19. I mean, I am at the end then. The fact that he has no friends in real life that aren't online. Well, since when is this a roast? Come on! There's nothing wrong with having online. Okay. Okay, here's the point. Hold on. This, alright? This. Please tell me it's online, because I kinda need it for my argument. Please tell me it's online. Please, I beg you. Just be online. Do you expect death soon? What kind of question is that? I don't expect to die. It's a possibility, I suppose. When was the last time you were outside for more than 60 minutes? I walk every single day, actually. Every single day at night, I go for a walk. Once I'm done with this stream, I also just go for a walk. And I walk from anywhere 40 to 2 hours. That's what I think. Okay, it's probably less than 60. Is that really the range at this point? I haven't died yet, so statistically I won't die. Immortal until proven otherwise. Yeah, open master, which is offline. Tefta, I was trying to dagnab it. I was trying to prove just how cool I am. 1960. That is a solid guess. I was like saying that's a solid guess. In the meantime, let me just bring up the samples a bit. So we do need to multiply by 16, unfortunately. I suppose I do act like one. I mean, apart from the blood drinking, I just consume newborns, but that's a vampire thing, isn't it? Oh, calculus, that's right, that's what we're doing. So, for calculus, this is actually going to be a pretty demanding file. How is this render doing? 35 frames, somebody sends 100, so 1/3 of the way there. Bro's in a YouTube stream with 7 people in it, for being antisocial, by the way. That's actually a pretty good point. I am very social, just not as a... I am social, just not in a way that normally people are. I just... You know, you can fill in the blanks, and then you'll end up with some sort of argument. Okay, this is pretty decent. I feel like I could scale it up, though. I could scale it up and scale it down. And still end up with something good looking. Right? Well, the gaps were getting larger now, yeah, so we'll have to scale it down a bit. I'm out of one of the other people, 6 out of 7. Wait, Bob, is that... Wait. Do you have 2 accounts, both of which are just called Bob? Because I'm pretty certain... Oh no, never mind. I thought the other Bob... I thought you just... Sorry, I thought that Bob had a different color before. Also now, can you help me understand simultaneously in the right angles? Yes, I can. Give me a second, let me just readjust this to be something more akin to 3. So, sine, cosine, tangent. Bob is the greatest name in the world, so shush and do your math, make it. Bob is funny, Bob is a good name. This is for the questions that make me sound dumb. No questions ever make anyone sound dumb. In order to ask the right question, you need to know the answer. But if you know the answer, you don't need to ask the question. I really don't like it when people are judged based on the kind of questions they ask. So, there is no such thing as a dumb question. There are dumb people who ask questions, but, you know, just the question itself doesn't determine whether someone's dumb or not. Lack of knowledge is not the same thing as being dumb. I don't have knowledge. You mean to call me dumb, wouldn't it? Like, just because you don't know quantum mechanics doesn't mean you're dumb. If someone explains quantum mechanics to you, and you kind of, and you study quantum mechanics, and then at the very end, even with all the knowledge of quantum mechanics, you still make wrong conclusions, that means you're dumb. But if you just don't know quantum mechanics, it doesn't mean you're dumb. The difference between knowledge and intelligence. Knowledge is knowing, intelligence is interpreting. To me, I'm that. No! That's. Wait, hold on. You're misunderstanding me pretty severely. You have knowledge, and then you have intelligence. Knowledge means knowing, intelligence means interpreting knowledge. If you don't know something, that just means you're unknowledgeable. That means you just don't know something. If you do know something and you're interpreting this data incorrectly, that means you're non-intelligent, in which case most people would define as dumb. So, for example, if how okay. So, for example, if you're in a room, right? If you are in a room with a button and a gun pointed at your head, this is a gun, right? I'm not great at drawing. This is a gun. If you're in a room with a button and a gun pointed at your head, then if you press the button, that's not necessarily dumb. But if someone walks into the room before you, presses the button, gun fires, they get shot, then you walk into the room, press the exact same button and you get shot once again, that means you are dumb because you had all the information you'd ever need in order to guess what's gonna happen once you press the button, and yet you didn't interpret correctly. I would press it, I want to die. I mean, that's the difference between being dumb and stupid. No, because lack of knowledge is not... I really don't like it, because lack of knowledge shouldn't be considered a negative thing. I mean, okay, it should be considered a negative thing, but it shouldn't be considered a negative quality. America approved. Lack of knowledge shouldn't be considered a negative quality of a person, because knowledge is dependent on what other people tell them. So, if you are dumb, then that's on you, because you can't interpret information. But if you are unknowledgeable, then that means people around you didn't tell you enough stuff. It's very sensitive about this. Yes, I am, because I am dumb, and I don't want to be mistaken with people who are unknowledgeable. That's the difference. Important difference, may I mention. Alright. Oh yeah, a car. Let's add a car to the scene. This, come on, Farm Explorer. Software, whatever. It's good enough. Spoiler lips. So you wanna stay antisocial? What? When? I don't wanna stay. I'm very social. What do you mean I'm very social. Friends on the internet, still friends. You're being very mean to me. Duh. Oh, whoops, wrong folder. Models. I doubt that. You are so mean. So mean. It's just so mean. What's going on? People on the internet still can be friends. There we go, I found it. I was delaying as much as I can. This is a car model. Wait, no, we don't want a car model. We want a Volvo S90 model. That's what we're looking for. We're gonna use a Volvo S90. I bully short people. How many people who you are friends with have seen your face? None. Absolutely no one, actually. And this is not even like on the internet. No one. I just don't show my face around. It's not even that I don't show my face on the internet. I don't show my face, period. It's just a thing. It's a thing that I have. So you wear a mask? Yeah, not the same one you see on YouTube, but yes, I do wear a mask all the time. Not mom seen it. I wasn't born, I was just made out of a test tube, and I just, you know. Can I join them together? Oh, of course it's not gonna work. Oh, never mind. I spoke too soon. And I clicked too soon. I might have also crashed everything. Blender? It just appeared one day and everyone accepted it. That's my origin story. Close program. Do you do YouTube full time? No, I don't. I would love to, but no, I don't. I don't earn enough money on YouTube to do it full time. How much do y'all think I earn on YouTube, by the way? Fun fact. How much do y'all think I earn on YouTube a day? With all of my videos, all of my shorts, all of my live streams, everything. Anyways, everyone's still wearing a mask now. You're gonna dox you're gonna check every single person on the planet. I want more vids. Listen, if I actually do, at some point, will be in a situation where I can do YouTube full time, I will. $50, 150, 50. The answer is $2. $2 a day! $3. $3 was the closest. The rest wrong. Yeah, $2 a day. Which, if you can do some quick math, 2 times 30, that means $60 a month. And funny story, in United States of Can I Get an Amen America, the lowest minimum wage is $7. The highest is 15 per hour, obviously, which means 7 times 8. So the lowest. Let's go with the lowest minimum wage in all the United States. That's 56, which means that people earn 56 a day on a working day. That's fine. That's 20. That's something like 24 a month. So 24 times 56, which is. No, it'd be too low. 24 times 56, which is 1,300. That's the minimum wage in America, which means that 44. Wait, that's percentage. Times percent is equal to this, so we have to divide both sides. So which means that 60 divided by 1344. I am actually 4%. I am earning 4% of a minimum wage. Put it down, everyone. Give me $20 right now. I mean, I don't mind it. I still work freelance in the meantime. I'm a freelance 3D artist and editor. Big shocking, alright? And you say there is 15. Yeah, in California. California has the highest, if I'm not mistaken. Either California or Washington. No, either California or Delaware or Washington. I don't know, one of these. Lowest is 7, highest is something around 15. I'm too young to send you money or would. I mean, you don't have to, it's fine. I'm still growing. My channel is still growing like crazy. So, right now I'm 4% of the way there. Which means all we need to do is just, what do you do for work now? I freelance CG animations, 3D animation, CGI editing, making ads mostly. I make ads and I hate that job. I don't like it, it's awful. It's boring, it's soulless, it's like education and entertainment, except with no educational value and lack of entertainment. Cool, it's not cool. I really hate it. When you get bigger, I feel like you would be great for Nebula. Right? Link in the description, nebula.com/makeit, where you can sign up for Nebula and get a one-time... I'm not sponsored by Nebula, but Nebula would be great. I would love to. I would love to join Nebula. Better wars than 9 to 5. Depends. It depends on the kind of person you are. Drink and walk, break my brain. 9 to 5 depends on the kind of person you are. I will sit now for it just for your vids. I will try. Okay, soon, real soon, in a month or so, I will have a really cool announcement coming, and then I will just have something. I'm just gonna foreshadow it on this live stream. Really cool thing coming, and that's gonna kickstart the whole Naked engine. It shows you this. Okay, so wait, what's the? Oh yeah, 9 to 5. What is better? That depends. For me, freelance is way better, but that's just because I'm really quick. I don't think I'm the best at anything. So when it comes to someone with as much experience with CGI as I have, most people would probably be able to do better renders, to do better scenes, do better modeling, better everything. But I am faster than them. So I'm not close to being the best, but I am fast, crazy fast. That's why freelance is great for me, because work that normally would take someone, I don't know, 6 hours to get through, for me it only takes an hour. That's why I really like freelance. The downside of freelance though is that you don't really... The biggest issue is finding work, which sucks. I'm not on Fiverr or anything, I just know a couple of small companies that every now and then give me something to do. Did you watch anything on Nebula? I don't have Nebula, it's money, expensive. Freelance is basically when... so you can work a 9 to 5, where basically you work in a company, and the company pays you. Freelance is basically when you have... Okay, so you can have a company, right? and then you work for company, and you have then clients. So you have clients and workers, and the basic the reason why companies exist is that they want to match different clients with different workers. The downside is you get a smaller share of your work, or reward for your work. The upside is there are always more clients. When you're freelancing, you just find your own clients and you just work directly for them, which is nice because like you don't have a boss. It's, you know, you're working on hours, everything is decent. The downside is you have to find your clients. So apples and oranges. That's good for us. The rendering bottleneck always makes efficiency quality all the time. Yes, rendering is massive bottleneck. I mean, right now on the other screen, right here, that's where this. I'm rendering stuff in the background. Each frame takes 32 minutes. I'm hoping you can see it. I know you can. I'm hoping you can see it. Okay, yeah, I could a single. People are leaving again, are they? What GPU do you have? GeForce RTX 360. Almost the 2-hour mark. Is it? Damn, it feels like 10 minutes. That's crazy. Oh, you can get the theme free by Soda KC on YouTube. youtube.com/soda@SodaKC. What was I doing? Oh yeah, right. I was trying to import a vehicle into my scene. Can I just Control Z? No, don't Control Z. Can I append geometry? That'd be nice. Not too much to ask. Could you show some of the work you have done for your freelancing? I tend to keep that pretty private. And also it's really boring. No, unfortunately, about 10 miles, I'm like, no, do I need 10-hour stream mark? That's pretty far. Let me show you kind of what it looks like. Some sort of corporate BS. Oh. Let me show you kind of the kind of things I would normally work on. So basically something like this.
Good morning, everyone. I'm Ashley Barrett, coming to you with an important update on behalf of our greatest hero and our most loving father. In the coming months, Homelander will stand trial for saving his son from a vicious Starlight-loving thug. An act of heroism, now somehow being branded a murder.
Yeah.
Make no mistake, Vought and its shareholders.
Do you do voice acting for anything? I don't know if I have a good enough voice for voice acting, honestly. For a really long time, I was really self-conscious about my voice because I feel like it's not good enough. I don't know, who could I voice act? Some the voice is so good. It is really good. I don't know why Vought International was the first thing that came to my mind, but wait, when you say you work on something like that, isn't that the real person doing the acting? You do yeah, I do the 3D animation editing. That's what I do. So I do the edits, I do the pop-ups, I do the 3D animations every now and then, and a couple graphics and stuff like these. And it's just awful. I hate it. I really hate it because no one cares. No one cares about this corporate bullshit. I'm sorry for, pardon my French, but really no one cares. I'm just making stuff because some guy at the top decided that it would be really cool to seeing just how much money they can spend on worthless videos. Thoughts on AI? I bet the video would be hell interesting. Oh yeah, video on AIs. If only I did a video on AIs. Oh goody. Oh no, I really should make like a I really should make a video about AIs. That would be just so great if I just made a video, but some plug. These two videos about their AIs, AGI, to be exact. Both kind of about the two different aspects of the same thing. This is my favorite video, topic-wise. That's less with the animations, but still great. I've never done anything with style like what is GitHub ad? Wait, GitHub ad as in single D or I still have finished. Okay. I'm back now. Well, welcome back then. You mean GitHub ad as in advertisements for GitHub or GitHub ad as in the style like the what is GitHub ad? What is GitHub advertisement? Yeah, because I'm just asking because I thought, oh, now I found it. Right when you answered, I found it. Well, egg on my face.
What do you mean, what is GitHub? It's the largest, most complete development platform in the world.
Oh, so you mean not garbage? I would love to make something like this, but no, I've never worked on anything like that. Because, yeah, it's obviously I didn't. Because these things are great, but they usually don't hire freelancers when they're doing stuff like these. I mean, I have made some ads for myself. I made an ad for myself. You know, a while back, I actually wanted to donate $300 to charity, but I didn't have $300, and so I just made hoodies, and this is an ad.
Have you ever thought, damn, I really wish I had a hoodie that would be one massive advertisement for a charity? Well, wish no more. With the brand new pre-300 exclusive charity checkup hoodies, you too can look fashionable while at the same time save me from willingly bankrupting myself on the 300 charity checkup. Each hoodie is handcrafted by yours truly and is made with a black hoodie, white logo, and unlimited supply of love.
This ad. It's great.
The offer is up to 300 checkup, this supply is limited, so get them while you still can.
I don't know if that website's even working anymore, but yeah, it's not. It's broken. But yeah, hoodies are no longer available. Hoodies are no longer available. They were available up to 300 charity checkup. And Ali and Tefta both bought them, and because of that I actually didn't bankrupt myself, and because of that I'm still here. And that ad was lovely, and I loved making it, and so now I'll make some more for Slice of Pie. And I actually want to make ads for myself, not soulless corporate BS. No likes, no one cares about. I'm having a lot of fun, I'm not gonna lie. Usually there are less people watching these live streams because usually I don't stream them on the main channel. Now we're almost 3 days in a row on the main channel. Wait, almost or exactly 3 days? Almost 3 days in a row on the main channel. I'm more confused now. So you freelance as a video editor? Yes. Well, video editor, CGI artist, cameraman, anything honestly that comes my way. When's the next live, by the way? Tomorrow. But tomorrow's gonna be a different one. Because right now is a Thursday, tomorrow is gonna be Friendly Friday live stream when I will stream Satisfactory with Tefta because I need to rest. I want to rest, I have to rest, I need to rest. Yeah, I stream them every day. This is daily serious live stream checkup. I've been streaming every single day for the past 380 days now? Yeah. 1 before 7. I have no idea when it's gonna be. Might be before 7. I can do it around 6, I think, or 5. Have you ever used Unreal Engine for any of your animations? No, because it's just like for animations, Unreal Engine is kind of like Blender except lower quality but faster. That's all it is. Unreal Engine is quicker than Blender, but it's also lower quality. Christmas and all the holidays included? Yeah, every single day. So I've basically spent an entire year streaming. As an Unreal animator, I think it's not really. Wait, but it's not really something to take offense on. It's more of a fact. Unreal Engine is way quicker than Blender because, you know, it can render in real time. But Blender is made for animating. Well, it's also made for other things now. Did you learn Blender and how long have you been using it for? 6 in 1 time zone, Central US time. I thought I'd really skip holidays. No, every single day. I've been doing Blender for 4 years now, I think, 4 or 5, something like that. So Robot Communist, do you plan to take over humanity as a dictator? In a string of questions. Casual. Unreal has good path tracing, it's just most people don't turn it on. I know it has good, but like... Blender has cycles. And I'm sorry, but Cycles is great. It's Cycles X. You can't really beat Cycles X. Cycles X is it's just best. Most people, okay, not most, but a lot of people render in Eevee, where, well, it's not great. I don't render in Eevee because it looks awful. It looks bloody awful. I mean, I'm pretty certain there are some ways to make it better, like Bloom, for example. Yeah, there's like a bit better. There's things, reflections. You can turn those things on, but it's still awful. That's why I just use Cycles. For all of my animations. Absolutely all of them. It takes a long time to render, but it's quick. Not quick, good. It's actually opposite of quick. It's rather slow. Oh yeah, I was trying to add a car. I keep forgetting what I'm doing. Oh, is it wrong version of Blender, by the way, to open the car? What Blender is this? Oh, 4.0! Never mind, I can just open the newest one. That's convenient. Where'd you get the car? Online! There are so many free models online. CG Trader, did you make it? I did not make it, but that's a good... Funny, because my name is Make It. I export it as an FBX, actually. Oh, I don't have to. It's already exported as an FBX. Import. Or maybe OBJ. Maybe OBJ is better. Nope. Only FBX. Got it. Because I want only a single object. It's not going to be single, is it? Can I dox you? I'd rather you wouldn't. Really mean thing to do. Just dox someone like that. Oops, I connected too many things. So I'm gonna... How would you feel if I doxed you, huh? How much longer is this stream going to be? Well, you have somewhere to be now, are ya? Oh, if you want to go, then just go! I'm sorry, it's a bonding issue, but, what do you mean active objects of the mesh? I feel like I, as long as I can go on, honestly. I still would like to, what do you mean object is not an active mesh? Active object, oh, active object, oops. There we go. That's our car. Oh, this is gonna take hours to render now. Boy, am I glad I'm doing this like that. Oh, that's great. She undocs me. So mean. You've been nothing but kind to you. I'm just straight to doxing. That's why we have taken an oath to be here for hours. Legally binding. I don't know if using a car is actually a good idea. Because first of all, it's gonna take hours to render a single frame. How could the angle of a right triangle, two sides are given? That's simple. You have two sides, you want to calculate the angle, right? I got the legal ego over here. Because you don't just need a legal team, you need the eagle team. Link is in the description. Anyhow, when you have a triangle, like this, you have maybe A and B. And let's say you want to calculate this right here, right? This angle theta. You wish you doxed me. Why? That's so mean. You want to calculate this, right? Then, here's what you do. You already know that, for example, sine, and you have hypotenuse right here. Sine is equal to b, sine of theta is equal to b divided by h. Which means if you want to get the angle, what you have to do is you have to use the arc sine of theta. Arc sine of b divided by h. That's what you want to do. If you want to get an angle theta, this is the equation. Really quick and imaginary girlfriend. I don't have an imaginary girlfriend, I have a real boyfriend. This is how we calculate an angle. I should really optimize this somehow. I should be gonna win. You confuse me even more. Well, that's the issue. This one is just a matter of remembering equations. I don't know. I'm thinking, how should I explain this? I don't know. Oh, he's gay? Oh, what? You have a problem with that? You have a problem with that, Medi? Chaudhary, you have a problem with me being gay? No. Do you not? Certain? Why'd you write in all caps then? I'm only gay when I'm talking with homophobes because that's funny. I like trolling them. The boyfriend who's never seen your face. Yeah, and I'm a heterosexual when I'm talking to people who don't like heterosexuals. I'm bi when I'm talking to people who don't like people who are bi. My political orientation depends on who I'm trolling. His boyfriend goes to another school. Yeah, you wouldn't know him. He's actually from Canada. Actually met him on spring break. You wouldn't know him. He goes to school in Canada. Yeah, he's actually older than me. His boyfriend is a minor. Don't start that, mate. Don't start the rumors. I do believe. What is accent? It's a function, just like sin. Just like sine. So you have sine of x, and this is a function, and then you have arc sine of x, and this is yet another function. It only goes from here to here because the total number of views and thousands on online videos modeled by function where t is number of days since the video was posted online. Describe the function as transformation as parent function of the graph. Use the graph to determine how long will take the video 50,000 times. Well, what is that equation? V of t is equal to 20 log 5 t plus 2 plus 5. Total number of views in thousands of an online video. What kind of homework is that? Transformation of its parent function, then graph the function. Transformation of its parent function. Thus thy father. Infill sin, it's about almost. It's an inverse sin. I'm pretty certain it's the same thing. Right? Is it? It seems to be negative first. Yes, it is. There we go. It is confusing, I know. But, it's curious. I mean, quite decent, but are actually very similar. Focus. Huh. Wait, could we do sine of y is equal to x? Oh, it's overlapping. That's fun. It is genuinely just this function rotated around this axis. That's fun. Sine to the negative first is genuinely just sine rotated around this axis. Is this or this correct? I mean, you always start with the... I mean, you always start with these brackets. Like, that's how I do it. I mean, I don't know what you're talking about. I mean, this is just used for creating... oh, damn it. I was about to make a really banger of a joke, but I forgot the term. Nah, I don't remember the term. No point in the joke. The curly brackets in C basically just mean a certain thing. I don't remember the name of it. What were we doing? Oh yeah, right. I was trying to optimize this. Ah, I feel like I should ditch the complex background. It's a bit too complex for this. Let's see if this will make things simpler. It's gonna blast a lot of light. There we go, much quicker, fantastic. Well then, what we can do is we can just generate array offset 0, 0, 1, so tiny offset also 5. If now, how much do we left? Can you remove the glass windows from the car to speed up? It wouldn't speed up by much, because I already have the light bounces set to 3, which means no matter if it's the glass or anything else, unless it's going off into space, it's probably won't go that far. Why did I start with cubes actually? Wait, hold on, that's a good question. There we go. Now what we want to do is we want to create another array, this time going in the same direction, only to the up, 0. There we go, should let a bit of light through. So basically you have to use cosine because cosine theta is the adjacent sine. Here's the thing. Remember, this is what you can remember. So ka toa. That's how I always remember. This is an O, this is an A. Sokatoa. It's a very handy tool to remember these equations, because then you can remember that sine of theta is equal to the so. So O and H. Opposite divided by hypotenuse. Ka, which means that cosine of theta is equal to adjacent divided by hypotenuse, and then toa, so tangent of theta, is equal to opposite divided by adjacent. What are those things? Well, when you have a triangle, when you're trying to calculate this angle, this is obviously the hypotenuse, this is the side that's adjacent to the angle, and this is the side that's opposite to the angle. So these are your equations. So you have to just take the accent. Yes, so these are your equations, and then if you want to reverse them, so if instead of getting the angle So instead of getting the ratio from the angle, if you want to get the angle from the ratio, then you have to use arc. So arc sine is basically the same thing except the other way. So if you add arc to the very beginning, then you just flip them around. There's no really stand feature, yeah. Trig as always. Is it a cosecant? I don't know. I don't remember the names. It's true, no, there are so many trig functions, and let's be real, no one cares about them. Thanks, no. Yeah, thanks 7 Asan too for explaining the rule. No one likes trigonometry. Because there are just so many functions dealing with circles. Also, sine has a definition using imaginary numbers, all funky. Screw up. Anyhow, this I should actually do it using, you know what, that's a dang decent idea. I can do it using geometry nodes. Back in geometry, we never told what sine, cosine and tangent did, only that we put them in calc and wrote down the answer. When I found a chart for it, my mind was blown. Yeah, right, it's always so explained the wrong way. There's one by way. Yeah, it's just too many functions. Yeah, right. So the grid with 3 by 3 and one even number, and we want it to be right here. We want to have 16. So 6. So that means 20 by 20, I think. We do this enough. Mesh points. Instance on points. And just a smaller grid. There we go. Then what we can do is, wait, why is it? Oh yeah, because it's not a perfect square. And then what we can do is actually change it 10. Divide this by 2. I said what's a perica? This, and then copy this right here. Instance plugged in, except this one will have a 2 by 2 and it would be a bit larger down maybe. Like this. Not too much, it might be a bit too much. There we go, that's a bit better, and then a bit smaller down the middle. Only 5 people? Wait, what? What do you mean only 5 people? YouTube tells me there are 8 watching right now. So I take arc cosine angle D to solve for angle D. You take... Wait, arc cosine angle D to solve for angle D? You take... Oh, these are way too small. You take arc cosine of the ratio to get the angle. So basically, the goal when you have a triangle, the goal is to using these two sides, right? These two lengths, to figure out this angle. That's why when you take this one divided by a, plug it into arc tangent. I'm pretty certain in this case, then you get the angle. Because the basic idea is. That's the goal. Using these two sides, figure out the angle. And this function gives it to you. Just divide one this tower. opposite by testing, yeah. Oh, I actually remember this stuff. 6 again, yeah, now it dropped down to 6. Now this looks decent though, but I would like to add a mesh, if I may. Bring out a bit lower, this one a bit higher. Hold on, I'll read the chat in a second. How do you take arc cosine, bro? I need to see. Okay, so arc cosine. I mean, you're asking me some real hard questions this time because trigonometry is just—it's just a function. That's the best arc cosine. You just plug it in, you read out the value, honestly. That's the best explanation I can give you. No, arc tangent. That's the best explanation I can give you. It's the same as taking square root of anything else, just the button to calculate. Yeah, that's actually also, once again, great explanation. In school, was it English or Polish? Polish, unfortunately. But I did study everything in English. Wait, let me know the answer. Do you say ad or advertisement? Ad or advertisement, depending on how I feel. What I feel like. So basically, oh, that's actually a great way. Wait, hold on. 7 Asan is gaming at the moment. 7 Asan is actually. Oh yeah. Listen, 7 Asan. So just like, for example, when you have. Okay. So imagine you have something like this. You have x to the 4th power is equal to y, right? If you know x, you know how to get y, right? Because Ctrl Z isn't working. Oops. Is it because I'm in edit mode? So, if you have x to the 4th power equal to y, if you know what x is equal to, if you let's say know that x is equal to 6, then in order to get y, you just do 6 times 6 times 6 times 6 and you get y. Now, what if you have the exact same equation, so x to the 4th is equal to y, but you don't know what x is, you only know what y is equal to. So you know that, for example, y is equal to 7. How do you get x from this equation? Well, the way you do it is you use the reverse function. So you use, instead of powers, you use roots. So you take 4th root of y is equal to x. And now you can solve it. This is the exact same thing. If you know the angle, then you would use sine to get the ratio. But if you don't know the angle, but do know the ratio, you would use arc sine to get the opposite, to get it the other way around. So basically, this is the same thing. X to the 4th is equal to y, and 4th root of y is equal to x. This is the same thing. So this equation is kind of the opposite of this equation. Only 2 people? What? My YouTube says 5. And the thing is, about time to end the live stream 2.5 hours later. Oh, gee. Okay, does that make sense though? I see. Does it make sense though? Because if it does, then that's the explanation. If it doesn't, I can keep going. How do I calculate though? Let me ask you another question. How do you calculate roots? How would you calculate the 4th root of, for example, 4th root of 23? How would you calculate this? And the simple answer is you wouldn't. You would plug into a calculator and get the result. The same thing with arcsine. plug it in. There is no way to calculate as a function. I mean, there is, but you don't want to worry about complex numbers. Brute force the root. Check every single number. It's basically equivalent of when you have 2x equals to 1, you have it divided by things like cosine. Yes. So sine and cosine tangent are periodic functions, right? That means same values repeat several times. Let's say you have a function f of x takes in a and outputs so a f b, but the inverse function would take b and give you the corresponding value. But remember, a function have one input, so has to be restricted to a certain domain. That is an explanation. Is accurate. That's an explanation to why it only goes like this and doesn't go all the way. You know, it has a domain. That's a pretty complex explanation. What he used to draw? You mean what this is Blender. This is Blender. In Blender you just have a drawing thing which draws in 3 dimensions and allows you to have these things everywhere. Math! No. Well, that's fun. Yeah, I feel like it's about time that we end the live stream. Do you use Blender default controls or I use... depends on what. I mean, I use tab for edit object, which I'm pretty certain is the default. But for moving the camera, I use Shift F, which is a custom control. For what else is there? I feel like I use tilde shift for switching to pose mode. Oh, shift tilde also appears to be this. Well, I'm showing you that. Hi there, Ezio. Oh, you've joined another awkward time. I was about to end the live stream. Anyhow, I'm gonna go walk on the video now because there's no work to do. It should be up on Sunday. I'm pretty certain I'll finish it tomorrow, but I'm gonna upload it on Sunday because I want to do weekly videos from now on. So each Sunday there'll be a new video. How'd you guys... I don't know how fun make it. That's dumb. That wasn't a good joke. So, have a good day or night. Thank you a lot. If you'd like to continue the conversation, I have a Discord server where I just chat. So would recommend. It's kind of fun. Anyhow, like 7:30 here in Idaho. Yeah, it's almost 7. It's actually almost 7:30 here too. It's like 4 hours away. Anyhow, thank you everyone so much for watching. As always, remember, link in the description, https://makedavidscharity/ you can donate to my charity DBS Alliance and get a slice of pie on yourself. On the screen, https://make.wtf/charity/ you can go donate to my charity DBS Alliance and get a slice of pie for yourself. For now, that'll be it. Thank you everyone so much for watching and have a great day. Bye. And for everyone else who'd like to continue the conversation, as I mentioned, link to my Discord. I can answer everything there. Anyhow, bye!